Okay, so dear students, let us solve question number 274 again, because in last time there was no sound in question number 274. So again I am solving. This is the common data question. This is the continuation of this question number 273, guys. Question number 273. This is 274. Again it should be 275, no issue. Okay, the same question. The block diagram of sampling and reconstruction of signal x of t is shown in the figure below. Here this is sampling process and this is the reconstruction. Okay, we want to get back original signal from its sample version. The sampling interval is given. The discrete time signal, they are asking the discrete time signal. So how to get discrete time signal x of n from the continuous time signal? So x of t is given, it is 2 plus cos 50 pi t, 2 cos 50 pi t. Simply in this you have to replace t with n into ts, where n is integer value and ts is sampling interval. So here n into 0.01 second, which is nothing but n upon 100. Okay, so now the discrete time signal x of n will be 2 plus cos 50 pi into n upon 100, n by 100. Okay, so x of n, discrete time signal x of n will be 2 plus cos, this is nothing but pi by 2 into n, guys. Correct? Pi by 2 n. Are you getting? This is what? Pi by 2 n. Cos pi by 2 n. So this is the process for converting continuous time signal into the discrete time signal. Simply you have to replace t with nts, where n is integer value and ts is sampling interval. So what is the right answer? 2 cos pi by 2 n. I think option C, guys. Option C should be right answer is this question. So this is question number actually 275. Next question. Okay, here number is missing. There is a mistake in number. So this is 275 and this is 276, guys. Okay, 276. Okay, now reconstruction, guys. Questions based on the reconstruction of the original signal. This is also very much important part. A signal x of t equal to 2 cos 50 pi t, same signal, but now this time sampling interval is 0.025 second and pass through an ideal low pass filter. Means ideal low pass filter should have this type of sharp cutoff. This is the sharp cutoff, correct? Sharp cutoff, and this sharp cutoff indicates it's an ideal low pass filter. Practical filters do not have this type of sharp cutoff. Okay, so in most of the case you will get this type of sharp cutoff, that is ideal low pass filter. Whose frequency response is shown in the figure. So frequency response of an ideal low pass filter is given. The spectrum of output signal will be, so you have to find the spectrum of output of the low pass filter, output of the low pass filter. So see here how to solve this question. Now see, this is the block diagram, complete block diagram, guys. Correct? This is the complete block diagram. First of all, this is the signal x of t and we want to convert x of t from continuous time to discrete time signal. So sampling process we will do. So here this signal which is having maximum frequency fm, guys, maximum frequency fm. In sampling process we will choose certain sampling frequency fs, which is nothing but 1 upon ts we can write, where ts is sampling interval, time interval between two samples, and xs of t is nothing but your sampled signal after sampling. So here this frequency xs of t will have multiple frequencies, which is nothing but n into fs plus or minus fm, guys. Okay, and if you want to write in radian per second, then here omega m, here it will be omega s, and here it will be n into omega s plus or minus omega m, guys. Okay, where n is integer value. For positive value of n you will get right sided spectrum, for negative value of n you will get left sided spectrum. Okay, and here it passes through ideal low pass filter. So the frequency response of ideal low pass filter looks like this. Omega here, cutoff frequency omega c. 0, this is the cutoff frequency omega c, and this is minus omega c. Let us mark this is 1. So h of omega. So this is the frequency response of low pass filter, ideal low pass filter. Why ideal low pass filter? Because there is a sharp cutoff. Okay, sudden change in magnitude you can say. So in output guys, here let us mark output y of t. Let us mark output y of t, that is output of the low pass filter. So here frequency you will get, see, this low pass filter will pass frequency. So let us consider, let us mark this is omega I, input frequency to the low pass filter. Just take notation omega I. So here input frequency is omega I guys, input frequency to the low pass filter. See, if omega I lies here, omega I, then it will pass through this low pass filter, and if omega I greater than omega c, then it will be rejected by, stop or reject, it will be rejected by this low pass filter. So in output, which frequency you will get? Omega I less than or equal to this one guys. Here omega I less than or equal to omega c guys. If omega I less than or equal to omega c, then it will pass through this low pass filter, and if omega I greater than omega c, then it will be rejected by this low pass filter. Okay, remember this thing. Now what about this one, n omega s plus or minus omega m? Already I told you in comprehensive course also guys, correct? In comprehensive course also. Let me repeat it again guys. So to understand this concept, let us consider this one guys. Here let us consider this one. Let us consider this thing. So see here, this is the frequency guys. Okay, this is the frequency, which is nothing but omega m. You can see here, you can see here guys, this is omega m guys. Here maximum frequency omega m, and this is nothing but minus omega m, and minus omega m. Okay, now this 2 is shifted right side and left side. So let us mark this is, here n is equal to 0, so it is nothing but omega m guys. Okay, what about this one? So 6, here let us mark n equal to 1. So can we write like this? This is nothing but 4 plus 2 guys, 4 plus 2. Now here sampling frequency is omega s is 4 and omega m is 2 guys. Omega is equal to 4, omega m 2. What is the relation? So 4 plus 2. So can we write like this? This is omega s plus 2 guys. Similarly, what about 10? So 10, can we write like this? Let us consider n equal to 2, that is 2 into 4 plus 2 guys, where n equal to 2. So what we can write? 2 into omega s plus omega m. Similarly, next 3 omega s plus omega m. Then next 4 omega s plus omega m. Okay, here this is minus omega m guys. This is nothing but what? This is again n equal to 0, but here this is minus omega m guys. Okay, so omega s plus omega m, omega s plus omega m, and omega s minus, here this one, sorry, omega s plus omega m and omega s minus omega m also guys. Okay, minus omega m you can say. So omega s plus omega m, 2 omega s plus omega m. So it will be what in general? N omega s, n into omega s plus omega m as well as minus omega m, because here omega m also there and minus omega m also there. That's why plus or minus omega m. Now positive value of n for the positive spectrum and negative value of n for the negative spectrum. If we put the negative value of n, then you will get left side spectrum, and if we put positive value of m, then right side spectrum guys. Why plus or minus m? Because maximum and minimum, omega m and minus omega m, that's why. Okay, so here different frequencies are present, omega m, omega s plus omega m, 2 omega s plus omega m, then here also same thing. Okay, so here in this concept, remember this in n omega s plus or minus omega m. Okay, now here, so low pass filter cutoff frequency is what, this one, 40 pi guys, 40 pi. Okay, 40 pi. Now sampling period, so x of t is equal to 2 plus cos 50 pi t guys. So here frequency is what, this is 0, and here frequency is 50 pi guys. Okay, 50 pi, and the sampling frequency omega s, which is equal to 2 pi by ts, 2 pi by ts. So 2 pi upon ts is 0.025. So I think it will be 80, correct, 80 guys, it will be 80. So the sampling frequency will be 80 pi. So what is the input frequency of the low pass filter? Input frequency of the low pass filter, so as I told you, nfs, n omega s plus or minus omega m guys. So here it is n into 80 pi plus or minus omega m, which is nothing but 50 pi, and DC also, this one also guys. Okay, so here n equal to 0, if you put n equal to 0, then you will get input frequency plus or minus 50 pi, correct. If you put n equal to 1, then n equal to 1 guys, if you put n equal to 1, then 80 pi, that is 130 pi and 30 pi guys. And if you put n equal to minus 1, then minus 135 minus 30 pi guys, and so on guys, and so on. You can put n equal to 2 also, you can put n equal to 2 guys. So here just you have to add 80 pi here, just you have to add 80 pi. So it will be 210 pi, and here 110 pi guys, correct. Okay, these are the different frequencies guys. Now here cutoff frequency is 40 pi, cutoff frequency is 45. See, DC also present, so this DC will pass, correct. See, DC omega equal to 0, this DC will pass guys, DC will pass. Now here 30 pi, see, plus or minus 50 pi, it will be rejected by this low pass filter, will reject plus or minus 50 pi. Now 30 pi and minus 30 pi, 30 pi and minus 30 pi, it will pass guys, correct. This low pass filter will pass 30 pi as well as minus 30 pi also, it will present. So here at omega equal to 0, then omega equal to plus or minus 30 pi. So low pass filter will pass these frequencies. Okay, then again 210 pi, this all will be rejected by this low pass filter. So here which option should be correct answer guys? Option B, you can see guys, only option B should be correct answer, only option B. See, omega equal to 0, 30 pi and minus 30 pi. So option B should be right answer of this question. As I told you, this is 4 pi. Now you can see here this is pi. Okay, in this question here, see, this is 4 pi, I told you, this is 4 pi and this is pi guys, 4 pi and pi. So here it is 4 pi and pi, minus 30 pi plus 30 pi. So simply you have to remember this concept guys, this concept, this one. Input frequency to the low pass filter is this one, n omega s plus or minus omega m, and output will be, if input frequency greater than omega c, then it will be rejected by this low pass filter, and input frequency less than omega c, then it will be passed by this low pass filter. Okay, simple concept. This is a simple concept that you can remember, guys. You can remember. Fine. So let us take next question. Question number 276. Now question number 277. Let us solve this question. Same question, guys. Now you can see same question. The signal x of t cos 200 pi t plus 3 cos 180 pi t is ideally sampled at a frequency of 150 Hz and pass through a unit gain low pass filter. Unit gain low pass filter with a cutoff frequency 110 Hz. What frequency components will be present? Okay. First of all, FM1. So correspond to this one, that is 100 Hz, and FM2, guys. So correspond to this one, that is 90 Hz. Okay. Now let us observe the sampling frequency. So sampling frequency is 150 Hz, guys. 150 Hz. So what will be the input frequency to the low pass filter? So omega I. So here F, guys. F, because in Hertz, Fi equal to N into Fs plus or minus Fm. So there are two cases because there are two frequency. So correspond to 100 Hertz, I am writing Fi1. So N into 100, sorry, N into 150, guys. Fs is same for both. So N into 150 plus or minus 100, and second case, second signal, which is N into 150 plus or minus 90, guys. Plus or minus 90. Now here I am writing different value of N. Correct? Different value of N. Corresponding frequency you will get FM1 and FM2. Correct? Different value of M. Here Fi1, Fi2, and here output of the low pass filter. Output of low pass filter Fi2. Here I am writing Fi1, guys. Okay. Now put N equal to 0 here. Put N equal to 0 here. N equal to 0. Then here plus or minus 100, and here plus or minus 90 Hertz. Yes or no? Are you getting? Then put N equal to 1. N equal to 1, guys. If you put N equal to 1, simply you have to add 150. So if you add 150, then it will be 50 and 250, guys. Correct? You have to subtract, you have to add 150 in each and every one. Correct? And here if you add 150, then it will be 40. Subtract and add 150, it will be 240, guys. 40 and 240, sorry, 60 and 240, guys. If you add, then it will be 240. If you subtract, then it will be 60. Are you getting? Now next again add 150 in these, guys. If you add 150, so it will be 200. If you add 150, it will be 400. Again add. You can take N equal to also. 300 plus 100, that is 400. 300 minus 100, that is 200. 300 plus 90, 300 minus 90. So again add 150 here. So if you add 150, so 210. If you add 150, then it will be 390, guys. Correct? And so on, guys. Now let us observe, and so on, guys. You can calculate. Now let us observe. Now next let us observe the cutoff frequency, guys. Cutoff frequency is here. Cutoff frequency is 110 Hertz. So if input frequency less than cutoff frequency, then it will be passed. It will pass by given low pass filter. If the input frequency greater than cutoff frequency, it will be rejected by the low pass filter. So 100, correct? 110. So this will pass. This also will pass. 50 will pass. 60 will pass. The next, then remaining all will be rejected. 250, 240, 200, 400. Okay. So 100, 50 and 90. 100, 50 and 90, positive side. 100, 50, 100, 50, 90 and 100. So 50, 90 and 100. Option A, guys. Option A, sorry, 50, 60. Wait. 50, 90, 60 and 100. So 50, 60, 90 and 100. Option D, guys. Option D should be correct answer here. Option D should be right answer of this question. Is this clear, guys? So this is very much important concept, guys. This is very much important concept. So this is question number 277 guys. Question number 277. Okay. Next question, question number 278. Okay. Now here same question, a sinusoidal signal 5 cos 800 pi t is sampled at a sampling rate of 6000 samples per second. So sampling frequency is given, Fs is 6000 samples per second, that is 6000 hertz. What about Fm? Fm 8000 pi t, so it is nothing but 4000 hertz. You can say this is 6k and this is 4k guys. Okay, and reconstructed with an ideal low pass filter having the transfer function this one. Okay, this is magnitude 1 by 300 between 300 hertz and minus 300. So this is nothing but simple low pass filter. It will be like this. So here this is 3k and this is minus 3k, and here this is 1 by 3000 magnitude guys between these two. Okay, this is given. Okay, no issue. So here cutoff frequency also given. Cutoff frequency of the low pass filter is 3k. Again same thing. So input frequency Fi to the low pass filter is NFS plus or minus Fm guys. NFS plus or minus Fm. So here Fi will be N. Fs is what? 6k. So here N into 6k plus or minus Fm. Fm is 4k guys. Okay. Now put the different value of N. You will get input frequency Fi, and you have to check output of the low pass filter. Okay. So now put N equal to 0 here. Simple. N equal to 0, then plus or minus 4k guys. N equal to 1, simply add 6k. So here if you add 6k, then it is 2k and 8k guys. N equal to 2, again add 6k guys. See 2, then 12, 12 plus 4, 16, 12 minus 4, 8. So add 6 here, that is 8k, add 6, that is 16k, and so on guys, and so on. Now what is the output of the low pass filter? Output of the low pass filter. So here if frequency greater than 3k, then it will be rejected by low pass filter. If frequency less than 3k, then it will pass by the low pass filter. So 4k reject, only 2k guys, only 2k will pass, plus or minus 2k. So 2k only guys. This low pass filter will pass only 2k hertz frequency. So which option? 2k hertz only guys. Option C. Is this clear? Very much interesting concept guys. Option C, very much interesting concept. So this is question number 278. Question number 278. Now same guys. Question number 279. Okay. Consider a signal processing system shown in figure, and input x of t is equal to cos 100 pi t. So first write data. Fm is equal to 50 hertz. Correct? 50 hertz. Okay. Is applied to the input with a sample at a rate of 100 hertz. So sampling frequency also given at the rate of 100 hertz guys. Okay. And 100 hertz through an ideal sampler. Okay. The output y of n is dash. They are asking the output y of n guys. They are asking output y of n. Okay. This is also simple question guys. This is also simple question. So x of n is given cos 100 pi t. Fm is given, Fs is given. So x of n. How to find first x of n, then y of n they are asking guys. X of n and y of n. Okay. So first of all you have to find x of n. X of t is given. X of t is equal to cos 100 pi t. Cos 100 pi t guys. Okay. So here t become nts. T become nts, which is equal to n into 1 upon fs. Fs is equal to 100, so it will be n upon 100 guys. So simply replace t with n by 100, so x of t will be cos 100 pi, replace t with nts, that is n by 100. Okay, so x of t is nothing but cos n pi guys, cos n pi, correct? Cos n pi is nothing but minus 1 power n, correct? It is nothing but minus 1 power n guys. Okay, it is nothing but minus 1 power n, correct? Minus 1 power n. Now here this h of z is given, h of z is equal to, okay, so this is x of n guys. Now here after sampling it is cos n pi guys. Okay, cos n pi is there, cos n pi, okay fine. This is x of n now, x of n, are you getting? See, this is x of n. Now I told you guys sinusoidal steady state response, do you remember? Sinusoidal steady state response concept guys. Here input h of z, sorry, here transfer function h of z equal to 1 minus 0.5 into z inverse guys, into z inverse. Now for the frequency response you can replace z with e power j omega, so 1 minus 0.5 e to the power minus j omega guys. So input is cos, so output will be cos, just a change in magnitude and phase angle, just a change in magnitude and the phase angle. So you have to find magnitude at input frequency guys. What about input frequency? So compare with standard format, input frequency is pi, so you have to find magnitude at pi guys. So if you put omega equal to pi, so 1 minus 0.5 into e to the power minus j pi, correct? Which is nothing but 1 minus e power minus j pi, cos pi minus j sin pi, cos pi minus 1, minus minus plus 0.5 guys. So it will be 1.5, correct? It will be 1.5 guys, it will be 1.5. So magnitude you got 1.5 guys, है ना? Magnitude you are getting 1.5. Okay, so simply ये magnitude is multiplied, simply magnitude is multiplied. So what will be output? So y of n will be 1.5 into cos pi n, simple. Okay, you can find phase angle also guys, you can find phase angle also, see here. So phi h at input frequency, that is phase angle of 1 minus e to the power minus j pi, of course it will be 1 plus 1.5, so sorry 0.5, here 0.5 also there, 0.5 into e to the power minus j pi, again it will be 0.5 minus minus plus, so angle of constant is 0 degree. Okay, so phase angle add, if you add phase angle then it will be again cos pi n only, cos pi n only guys, correct? Cos pi n only. So the final answer, magnitude multiply phase angle add, sinusoidal steady state response, magnitude is multiplied and phase angle add guys. So what is the answer? What is the answer guys? Here the correct answer is option B, simple question, correct answer is option B. So this is the question number 279. Okay, now here question number 280 guys, question number 280. Okay, question number 280. How many sample values are required to produce enough information to exactly describe the following band limited signals? How many sample values are required? See, they are asking, indirectly they are asking what? Minimum sampling rate. You can see here, how many sample values are required to produce enough information to exactly describe the following band limited signal. Okay, so the meaning is what? They are asking minimum sampling rate. What should be the minimum sampling rate guys? Minimum sampling rate. So here fm1 is equal to 7 by 2, simply omega divided by 2. See, omega m is equal to 7 pi, so simply divide by 2 pi, so it will be 7 by 2. 7/2 hertz, and here FM2 will be, it is divided by 2 pi, that is 2 hertz, guys. Okay, so what is the Nyquist rate? Minimum sampling rate. Okay, Nyquist rate is nothing but minimum sampling rate, that is twice maximum of FM1 and FM2, that is twice into maximum of 7/2 and 2, guys. So 7/2 is nothing but 3.5. Okay, 7/2 is nothing but 3.5. So here it will be 7 hertz. So Nyquist rate, minimum sampling rate, is nothing but 7 hertz, and one more unit is what? 7 samples per second. This is the sampling rate, Nyquist sampling rate, 7 samples per second. So how many sample values? So 7 samples. 7 samples are required to produce enough information to exactly describe the following band limited signal. 7 samples, guys. Are you getting? Simple. They are asking minimum sampling rate, that is 7 samples per second. 7 samples per second. Okay, they are asking 7 samples per second, guys. Okay, so this is question number 280. Okay, now next, a signal x of t 10 sin 200 pi is sampled at 400 hertz, with the first sample being taken at t equal to 0. What is the value of sixth sample? What is the value of sixth sample? Okay, yes. Now see, sampled at 400 hertz, guys. Sample at 400 hertz. So here sample at 400 hertz. So x of t is equal to 10 sin 200 pi t, guys. 200 pi t. Now we are doing the sampling process. Sampling process means simply replace t with NTS, guys. T with NTS. Okay. Now here if we put n equal to 0, then it is a first sample. So they are saying that, see, first sample is being taken at t equal to 0. So at t equal to 0, first sample, t equal to, then next see, t equal to 0, first sample, guys. Okay, t equal to 0, first sample. Now here sampling period, sampling frequency is given 400 hertz. Fs is equal to 400 hertz, guys. So Ts will be 1 upon 400, guys. Okay, so first sample at t equal to 0. Then what about second sample? So 2 times Ts, guys. Sorry, then second sample t equal to 0, first sample, then second sample 1 upon 400 second, then third sample 2 upon 400. Are you getting? See what I am saying, guys. This is your sinusoidal function, guys. Okay, first write this one, n into 1 upon 400. So simply replace n upon 400, guys. So x of n will be 10 sin 200 pi into n upon 400. Okay, so 10 sin, it will be pi by 2 n, guys. Okay, now here this is the sinusoidal signal. Simple, I am writing only for the positive time for simplicity. Sine function, okay. Here what is the fundamental time period? So Fm is equal to 100. So Tm, which is equal to 1 upon 100, guys. So this is 0, this is 1 by 100, this is 1 upon 50. Are you getting? 1 by 50, guys. Correct. Here Fm equal to what? Fm is equal to 100 hertz. So what is the fundamental time period? 1 by 100 second. So 1 by 100, 1 by 50. Now they are saying that first sample, see, first sample being taken at t equal to 0. So at t equal to 0, first sample, then n equal to 1, then second sample we can say, second sample at, this is the second sample at 1 upon 400, correct? This is the first sample, guys. So this is first sample guys. Okay, first sample at n equal to 0. You can say this is the second sample. So second sample at, we can say t equal to 1 upon 400. Okay, can we say like this? First sample at t equal to 0, second sample at 1 upon 400, guys. Second sample at 1 upon 400. So what about sixth sample? What about sixth sample, guys? So can we say sixth sample, which is nothing but, can we say, see, third sample 2 by 400, fourth sample 3 by 400, fifth sample 4 by 400, and sixth sample, can we say 5 by 400, guys? 5 by 400. So simply here you have to put 5 by 400, guys. N equal to what? 5. Because they are saying first sample at t equal to 0. Remember this thing. Because they are taking first sample at t equal to 0, starting from t equal to 0. So that's why for sixth sample, n equal to 5, guys. N equal to 5. So simply you can put n equal to 5 for the sixth sample. Okay, n equal to 5, guys, here. Are you getting? N equal to 5. N is equal to 5. So 10 sine. Here, if you put n equal to 5, then here 5 pi by 2, guys. Okay, so 10 sine, here 2 pi plus pi by 2. Can we say like this? This is nothing but what? 2 pi plus pi by 2. See, pi by 2, then 3 pi by 2, again 5 pi by 2. So value 1, guys. 2 pi plus pi by 2, value 1. So answer is what? 10. Answer is what? 10, guys. Can we say like this? Answer is 10, guys. Okay, answer is 10. Answer should be 10, guys, and answer should be 10. Here we can see 1 by 50, 1 by 25. So 1 by 100 plus 1 by 100 plus 1 by 25. So it is 5 by 100. Yes, you can check, guys. 5 by 100 next. Next here 5 by 100, guys. Here also you can check. Here also you can check 5 by 100. This is what? This is 1 by 100. So can we say this is see, this is 100. This is 100, guys. Okay, this is 100. Add 1 add 1 by 25, guys. This is 1 by 100 and add 1 by 25. This 1 by 25. So it will be what? It is 5 by 100, guys. It is 5 by 100. That is 1 by 20, guys. That is equal to what? 1 by 20. Correct. Okay, this is 1 by 25. This is 1 by 50. This is 1 by 100. In 1 by 100, add 1 by 25. This much. If you are by 25, this is 4 plus 1. So here it is 5 by 100, guys. Okay. Just wait for a minute. 5 upon multiply with 4. Okay, wait. Yes. Okay, wait. 5 by 100. Correct. 10, guys. 10. Okay, 5 by 100. This is sixth. Correct answer is 10, guys. Your right answer is 10. Simply you have to put n equal to 5. N equal to 5. Okay. So 1 by 400. Then 2 by 400. So which is, this is equal to 1 upon 80. 5 by 400. N equal to 5, guys. Just wait for a minute. So n equal n by 400. N by 400. So this is pi by 2 n. N equal to 5. 5 pi by 2, which is equal to 1. So it should be 10, guys. It should be 10. Value is 10 because sin pi by 2 1. So value is 10, guys. Correct? Okay, value is 10. Okay, fine. We are writing t here. That's why we are writing t here, guys. Writing this is correct, guys. 10 is the right answer. Correct. Okay, here correct answer is 10, guys. Right answer is 10. Okay, correct answer is 10. Fine. So first ampere t equal to 0, then second 2 by 400, then 5 by 1 by 80. Okay, it's right, guys. Right. Wait. 1 by 100. Okay, this is correct on. Yes, this is right, guys. Yes, this is right. 1 by 20. Yes, this is correct. Okay, fine. Now next question, guys. Next question, 282. 282, guys. Question number 282. What is the minimum allowable sampling frequency for a signal x of t equal to 10 cos 800 pi t? Minimum sampling frequency they are asking. What is the minimum allowable sampling frequency? Okay, so you can see here, guys, here fm is equal to 400. They are asking in hertz, that's why 400. Here see fm equal to 900. See here cos 1800 pi t. So for this fm is equal to 900 hertz. Fm is equal to what? 900 hertz. Okay, but here after taking square, here it will be double. Taking square, that is 800 hertz, guys. Okay, now here there is a multiplication. So after multiplication there will be two frequencies, fm1 plus fm2, fm1 minus fm2, two frequencies, fm1 plus fm2, fm1 minus fm2. So it will be 2200 one frequency, and second will be 1400, guys. Can we select after multiplication? After multiplication, x of t equal two frequency, 2200 and 1400. Okay, here frequency 400. Here after taking square, frequency will be 1800. After multiplication there will be two frequencies, fm1 plus fm2, fm1 minus fm2, and finally they are asking the minimum allowable sampling rate. Minimum, that means Nyquist rate, guys. Nyquist rate is nothing but twice maximum of these two, guys. Maximum of these two. Correct? Maximum of these two. So here 2 into 2200, which is nothing but 4400 samples per second, or hertz, guys. They are asking hertz. So 4400 should be right answer of this question. So this is the question number 282, guys. Correct? Question number 282. Okay, fine. Now next question number 283, guys. Okay, now here consider a signal with amplitude spectrum x omega shown in figure below. The Nyquist frequency for the signal g of t is equal to x of t cos 10t will be equal to. Okay, if you multiply any signal with cos function, then it will shift right side by certain frequency, left side by certain frequency, and amplitude is decreased by factor of 2. Modulation property, it is known as modulation property. What I am saying, if the Fourier transform of x of t is x of omega, then if you multiply x of t with cos omega ct, in communication you might have studied, then the spectrum will shift right side by omega c, left side by omega c, and amplitude is decreased by factor of 2, guys. Okay, so right side by omega c, left side by omega c, amplitude is decreased by 2. So here omega m, guys, omega m for this is nothing but 1. Now if you multiply with cos, guys, if you multiply with cos, then this function will shift right side by 10, left side by 10. Okay, so it will shift right side by 10, left side by 10. So it looks like this, guys. It looks like this: right side by 10, left side by 10. Okay, so right side by 10, that means so it will be like this. So right side by 10, similarly. Okay, so add 10 here, so this will be 9, this is 10, and now this is 11, guys. Okay, here this is -9, -10, and -11, and this amplitude is decreased by factor of 2, so it will be 1/2 after multiplying with this. So what is the now maximum frequency here? What is the maximum frequency? Now the maximum frequency is 11, guys. 11 radian per second, correct? This is g of omega, Fourier transform g of t. So maximum frequency here you can see here 11, guys. 11. So what is the Nyquist rate? They are asking Nyquist frequency. Nyquist frequency, that is a double of this one, radian per second. So double of this one, which is nothing but 22, guys. 22, double of this one, which is nothing but 22. Okay, 22, guys. Now next is question number 284, guys. Question number 284. A signal has the following Fourier spectra. Okay, what is the Nyquist sampling rate in kilohertz for signal x square? Okay, after taking square, the frequency will be double, guys. Here frequency is omega m, it is 400 pi. And if you do the squaring operation after taking square, so what is the frequency of this one? So here frequency will be double, that is 800 pi, guys. 800 pi. Okay, so if you are writing fm, so it will be divided by 2 pi, that is 400 hertz. 400 hertz, guys, correct? 400 hertz. 400 hertz. Okay, so what is the Nyquist sampling rate? Nyquist sampling rate is nothing but double of fm. So here this one fm dash I am writing, fm dash. Okay, so double of fm dash, that is nothing but 800 samples per second or 800 hertz after taking square. Okay, maximum frequency is 400 pi. After taking square, the maximum frequency will be 800 pi, double. Okay, then fm is 400 divided by 2 pi, so the Nyquist rate will be 800 hertz. Okay, now question number 285. Okay, if the Nyquist sampling rate for x1 of t, x2 of t are n1 and n2 respectively, the ratio n1 by n2 is dash. Okay, x1 of t is given, x2 of t is given. Sync function, guys, sync function. So here fm1 will be here 100 pi, guys, that is 50 hertz. Here frequency fm2 will be 100, guys. Now multiplication is there. Multiplication, see, multiplication of sync and cos. So x1 will have two frequencies, fm1 plus fm2 after multiplication fm. So here fm1 minus fm2, 150 and 50 hertz, correct? Addition, in multiplication addition, fm1 plus fm2, fm minus fm2, difference and addition. So what is the Nyquist rate? That is here Nyquist rate will be twice of maximum of these two frequency. So 150 and 50, guys. Okay, so here 2 into 150 which is nothing but 300 hertz or samples per second. If I am talking about second signal, 100 guys, 100. Okay, so I think there is mistake here. Pi should not be there in sync function. Just remove this pi guys. Then and then fm1, because sync, suppose sync 100t, then it will be sine 100 pi t divided by 100 pi, correct? Sin x by sin pi x by pi x guys, sin pi x by pi x, so 100 pi t guys. Are you getting? Sync 100 t is equal to 100 pi, so here pi should not be there, like this. So here sync function, again here frequency is 50 guys, correct? fm 50, but after taking square, x2 will have frequency fm double, fm will be double of 50, that is 100 guys, 100 hertz. Okay, so what about Nyquist rate? So Nyquist rate will be double of this one, which is nothing but 200 hertz. 200 hertz guys, correct? Which is nothing but 200 hertz. 200 hertz guys, है ना? 200 hertz. Okay, 200 hertz. So they are asking, this is n1 guys, n1 is nothing but 300, and here n2 is nothing but 200. Okay, so n1 by n2, which is equal to 300 by 200, which is equal to 1.5 guys, which is equal to 1.5, correct? Which is equal to 1.5. Is this clear? Which is equal to 1.5. So answer is what? 1 point, ratio is 1.5. So total 285 question in this series we completed guys. Okay, so this is all about sampling and sampling theorem guys. This important concept, sampling and sampling theorem. Now only last chapter left, that is DFT, discrete Fourier transform. So I will provide certain questions based on DFT also. So total 285 questions we completed, and more 15 questions we will see. Okay, more 15 questions also we will see, but in next part. So total, instead of 200, 300 questions extra I provided, along with comprehensive course. Here I am providing extra 300 questions also for the practice and for the revision. Okay, and to increase the confidence, new questions, okay, other than PYQ questions. Okay, fine. So all of you, thank you so much.